Today I'm going to introduce loops, iteration. Iteration is another way that Python can perform the same or very similar operations over and over and over again. In the last video, I talked about recursion. Recursion is a structure wherein a function calls itself, passing a different argument for the parameter. Or for the examples we saw, there was just one parameter. So recursion, as you remember, can be used to accomplish tasks like calculating mathematical sequences. We looked at the factorial example. I didn't talk about it, but the Fibonacci sequence is described in the slides. Anytime really that you have a general case and a base case, kind of at the most basic level. Iteration is somewhat similar in that it carries out a task multiple times, but I shouldn't say it functions, it works a bit differently. And it's structured a little bit different in Python syntax. Iteration is the process of the repetition. Now the structures it relies on are called loops. There are two looping structures built into Python called for loops and while loops. And each one of those makes use of the given token or a little word, so to speak. Call that a token. So a for loop carries out a set of statements for each item in a specified sequence. The while loop carries out a set of statements over and over again as long as a certain criterion, type that word, but you can sub in condition, that makes sense, as long as a certain condition is true. And it can be thought of as nested if branches. This next slide shows a simple while loop example. For the first line, x is assigned a value of 10, and then the while loop. So you have while x is greater than 0, so that's just a Boolean expression that can be evaluated to true or false. When it's true, the statements within the body of the while loop, so indented on a lower line, are going to be executed. So print x, and then x is assigned a new value, 1 less. X equals x minus 1. And we call that process of changing the value of x decrementing it. Could be incrementing it if you were increasing, like so. But if we were to increase x value rather than decrease, given this condition, the while loop would execute over and over and over again. Typically, you set your condition and then the change to the value of x in a way that this condition will be true for a certain number of runs, but then would be false. As long as the condition in the while loop is true, these statements will execute, and then the flow of execution will loop back up to evaluating that condition again. When it's false, the flow of execution would just skip below. So that's to say what statements get executed in what sequence. So I'll show this as a demo in idle here. Open a new file. X equals 10 while x is greater than 0, colon, print, oh, I'm in Python 2, so I won't use the parentheses, print x, and then assign x a new value, x minus 1. Save that. While loop. Save that as a .py file. And then I'll run the script And so in the shell here, the first value that gets printed is 10, second is 9, all the way down to 1. So this print statement, which I just typed once in the script, it is executed 10 times. Because x starts at a value of 10, 10 is printed, and then x is changed to a value of 9. 9 is greater than 0, so that condition is still true, so 9 gets printed, and x becomes 8. 8 is greater than 0, and so on. All the way down to when x is 1, 1 gets printed, and x becomes 0. While x is greater than 0, if x is equal to 0, that condition is false, and so these statements are not going to be executed again. If we revisit the example of countdown, we can put our while loop in a function and have the function accomplish the same thing. You might notice that the script doesn't have the while loop within a function, but it could. If I highlight everything and push tab, I can move it all over. I can define a function countdown and have one parameter called x, and then get rid of that assignment statement. See if that runs. There we go. And so the only thing we need to do now is print the word blast off. Print, caps lock, print blast off in quotes because it's a string. Save that, run that. Oh, I'm getting blast off printed after each number. That's not what I want. Kind of getting ahead of ourselves there. What's happening is because this blast off print is within the body of the while loop, it's kind of below it and one tab in, it's going to get printed each time we pass through that loop. In order to get it to print only once at the end, I'm going to bring it to the left one tab spot. Save that, run it again. Oh, there we go. Gotta resize the window, but we'll see. We get just one appropriately placed blast off. So this statement, print blast off, is only going to be executed after the while loop has run its course, after this condition is false. We'll see. So for recursion, a function calling itself, by definition, that has to be a function. While loops don't have to be structured within a function, but they can. So each one of these countdown functions will generate this output. You can do it either way. So here's another while loop example, not in a function, just kind of a simple x is assigned a value of 0. The condition here is while x is greater than 50, print x, and then increment x. So this is similar to our first example. We can just change it within our functions. Shouldn't call it count down, call it count up. Save that, run that, let's see. Didn't change this value, so the condition was false from the start. While x is less than 50, not x is less than 0. There we go. So now we're starting at 10, which is just the argument that I pass. So 10 is the initial value of x. So 10 is the first value that gets printed because x is less than 50. And then x becomes 11. So we count up from 10 all the way to 50, or to 49, I should say. We put an equals sign there, we can get all the way to 50. And then blast off gets printed. There we go, finally got to 50. So that process of incrementing or decrementing the while loop variable is so common and so fundamental to while loops that there's actually a simpler way to type that. For x equals x plus 1, you can write that same change as x plus equals 1. And if you want to decrease the value of x, x minus equals 1. So here, what I would be rewriting is this line, x equals x plus 1. Just call that x plus equals 1. I'll go down from 50 to 15 so we can get a good, easy view of this. 10, 11, 12, 13, 14, 15, blast off. So it functions in the same way, just saved ourselves a couple of keystrokes. But if you see a plus equals or a minus equals, that's what it is. Now, if we didn't have this, what would we expect to see? So x is still going to get printed, 10, and that's still going to loop through. So what we'd see is 10 is printed. 10 is less than 15, so that it is still true. 10 gets printed again. 10 is still less than 15, so we see 10 printed again. We'll take our run. What do we get? 10, 10, 10, 10, 10. It's going to keep going until it just reaches the limit. The computer cuts itself off. So we need to change x in such a way that this condition will become, at some point, false, or else just keep going. Here's a little bit of a more complex while loop I posted. Defines a function called find7. Gonna find the nearest larger number relative to the input x that's divisible by 7. So you can set up, instead of a Boolean expression, just a Boolean value while true. So this just means keep going, keep going. While true, print x. If x is divisible by 7, so if the remainder from x divided by 7 is equal to 0, really asking is x divisible by 7, print found a number divisible by 7 and then x. And then the line return x. So with a return, it doesn't even have to be return x. It could be just return. The function will exit. It will exit the function. So the while loop, in this case, will keep on going, like here. I might just have to cut this off. Ooh. But there is, by virtue of this return keyword, which will exit out the function, a way that you can stop. I want to kill it. Ooh, done. Kept going because we didn't change the value of the looping variable such that the condition would become false, or we didn't build in a return at any point. So those are while loops. They operate as long as that criterion, that condition is met, is true. For loops will repeat, will have the statement in their body execute over and over again, once for each item in an input sequence. And so we know one type of data that is structured as a sequence, and that's the data type of string. So here's an example of how to set up a for loop. You have a variable, here it's called EG underscore string, assigned a value that's some sort of a sequence. So a string is a sequence of individual characters. Those could be letters, punctuation, space, or numbers. We can call it Python 2.7 programming. It could be numbers within a string. They're just an item in the sequence. So the for loop is set up like this. For a variable in the name of the sequence, colon, and then on a new line indented in the body of that, some sort of statements. We'll take a look at this example in just a second. EG, still working within the same script, EG string equals, this is an example string sequence. I'll set up the for loop, type for I in EG underscore string, colon, return, print I. Save that, run it. Oh, so there's the output. I kind of kept writing a little on and on. We get one letter per line for each letter that's in this string. And now the I here doesn't have to be I. Change it to the letter J. And here we go, same output. Can be named whatever you want. I mean, you still have to follow the variable naming conventions, but it doesn't have to have anything to do with the initial variable, the sequence variable. If we change the name of that, though, we'll get an error. As long as for your looping variable is referred to as the same way. So I can't have it be I here in line 4 and line J and call it J up in line 3. It's just got to be the same. So what we've been doing, kind of executing the statements in the body of these loops over and over again, the word, the kind of vocab for that is called traversing the loops, kind of going through them again and again and again, and we traverse that group.